Okay, so last class, which is yesterday, we look at relation, right? The reflexive have to have ARA, symmetric. If you have ARB, you have to have BRA. Transitive, if you have ARB and BRC, meaning you match up the B, then you have to have ARC. And if you have those three, then we have the equivalence relation, right? And we also look at irreflexive, in which you cannot have ARA. Asymmetric, if you have ARB, you cannot have BRA. All right? Meaning you cannot have ARA because A is B, meaning B is A, right? And antisymmetric means if you have ARB and BRA, A has to be B, meaning you cannot have both pairs, right? It's the exactly opposite of symmetric, actually. Because symmetric, you have to have both, but antisymmetric means you cannot have both the different ones at the same time. So today I want to continue with the matrix of relation. Okay, then we put up the matrix. So for the matrix for reflexive, right? What do I call it? Reflexive. Okay. You have to have ARA for all A. So you don't know how big depending on the A, right? A is how many? Say maybe N. Then you know that you have to have, oops, just 3. You have to have this in the diagonal because you have to have 1, 1, 2, 2, 3, 3 until, and the rest, when you see the star here, doesn't matter. Okay, it doesn't matter. It can be anything. Okay. The second one is symmetry. Okay, the second one is symmetry. I put here 1 for this one, yeah? Okay, because this is all relation. R2 symmetry. Okay. This one says this can be anything, doesn't matter, because if you have 1, then it's okay. If you have 0, then it's okay. Okay, on the diagonal. But if you have 1 here, you have to have 1 here. Okay, they both have to be. If you have ARB, then you have to have BRA, vice versa. Meaning if you have 0 here, you have to have 0 there, symmetrically. Or in general, if you have a star here, then you have a star there. And the diagonal is like a mirror. Okay, that's symmetry. Mij is Mji. Okay. Symmetry. I skip 3 first, right? Because 3 is different. Okay. 4, 4. For irreflexive, okay, for irreflexive, you cannot have this. You cannot have ARA. Meaning, these all have to be 0. And the rest does not matter. Okay? So it's the opposite of this one. That one has to be all ones. That is for irreflexive. Now for asymmetry, I want to make sure my term is right. It's not asymmetry, asymmetric. Okay, can you please, my notes is page 90, asymmetric, anti-symmetric. Maybe I got from different books. Okay, later on, I will check, because some books you see, some books you see. But anyway, for anti-asymmetric, you cannot have, if A or B, you cannot have B or A, meaning you cannot have one here. So this has to be all zero. Because one R1 is one R1, right? So it has to be all zero. And if there is a one here, the opposite one has to be the opposite, zero. If there is a one here, the opposite one has to be zero, because you cannot have at the same time. Okay. Okay. Now, what about anti-symmetry? This says the only one that you can have is the diagonal. Okay. The diagonal can be 0 or 1s. The diagonal can be 0 or 1. So I put a star here. Star can be 0 or 1. The diagonal. Because diagonal means they are both true, right? It's A is B. Doesn't matter. And the opposite, you cannot have this at the same time. Meaning, if there is a 1 here, there has to be 0 here, like this, right? The difference is this one. It's 1 here, this has to be 0. So the opposite needs to be 0. Okay. Okay, the rest would be just examples. I go to the last part, which is the digraph, right? Digraph. Okay. Now, digraph is like a graph with the set A as the vertices. Okay, digraph of a relation. I will start with a set A. And a relation. So R 1 1 1 2 2 1 2 2 3 3 3 4 4 3 4. Okay. We can try to write out the matrix of relation. So MR, right? 1 2 3 So whenever you see, you will put a 1. Fill out. So we have 8, right? 1, 2, 3, 4, 5, 6, 7, 8. You will have 8 in the entry. So 1, 1, 1, 2. This is the first one, is the row 1, 2, 2, 1, 2, 2, 3, 3, 3, 4, 4, 3, 4, 4. Okay, so from here, you see, try to think whether it covers the whole of the relation. Okay. Atif, are you here? Is it reflexive?
Yes.
Yeah?
Yes, no.
Yes. Okay, reflexive. Since AA in R for all A in A. 1, 1, 2, 2, 3, 3, 4. Easy, right? From the matrix. Number 2. Is it symmetric? Emilia Eliza. Are you here? Emilia?
Yes, Prof.
Yeah. Is it symmetry?
Not symmetric
Why?
because
If it is not, then you give me one reason, counterexample.
it's not in R. It is symmetric. Prof.
Symmetry, right? Because if you look at mirror, then you flip, it's a symmetric matrix, right? So ARB implies BRA, right? Since AB in R implies BA also in R. Okay, like this one, right? This symmetry. This is much harder. You have to check. I just write. I didn't say yes or no. Wait until you decide. Okay, Zurin. Are you here?
Yes, Prof. Yes,
Right?
yes.
Transitive. You check this one. No, you don't need to check the 1, 1, 2, 2, 3, 3, 4, 4, right? You check the rest. 1, 2, 2, 1, 1, 1, yes. 2, 1, 1, 2, 2, 2, yes. 3, 4, 4, 3, 3, 3, yes. 4, 3, 3, 4, 4, 4, yes. Right? So I ask you, I give you the answer. I just copy the definition actually. Right? Because that is how you prove for all. If you want to list everything, it would be, but you need to check 1, and then the other way around 2, 3, and then the other way around 4. 4 times, yeah? Okay. Next, I want to know whether it is irreflexive. Of course, no, because we have 1, 1, right? You cannot have 1, 1. Okay. Asymmetry, no, because you have 1, 2, and 2, 1, right? Not asymmetry, and also not anti-symmetry because of the 1, 2, 2, 1. So if you have a pair like this, definitely it's not asymmetry or anti-symmetry. That's the easy one. Okay, there's something in the chat. Well, it's better to use the definition to prove. Matrix actually is just a way to check your answer, but you have to write out from the definition. Okay, in many cases, it's not accepted to just mention in the matrix. You cannot say because the opposite or MIJJ, because it comes from the definition. So better to check, to see from the matrix, but write your answer or your reason from the definition. Okay, just write out the definition. Okay, it's a very good question actually. Okay. Now we want to actually go to the digraph of a relation, yeah? So what you will do is, okay, to draw the vertices. It can be anyhow you draw it. So you write like this. I normally will do it clockwise, but it doesn't matter actually. It depends. So the answer is not unique, right? You can put the other way around, you can crisscross, right? But better to follow, to do it clockwise would be easier for me to check. And then you go through one by one. 1 to 1 is a directed, yeah, a directed one. Or if you want to follow clockwise, you do clockwise. Okay, 1 to 1, clockwise, yeah. Then we have 1 to 2. 1 to 2. Okay, 2 to 1. 2 to 2. 3 to 3. 3 to 4. 4 to 3. 4 to 4. Okay, it's easy, right? So also from this, if you have 4 loops, then you can see it is reflexive. You have 1, 2, 3, 4, 4 loops. Okay, it's also symmetric if you can see both ways like this. If there is a 2, 3, but there is no from 3 to 2, it's not symmetric. Okay. If you have like this different one, it is not asymmetry and anti-symmetry. If you have something like this, okay, this will be reflexive. This will be symmetric. When you check the from the matrix of relation, sometimes students don't like to try to memorize the MIJ, the MJI. So you just check from the definition of the asymmetry, right? The asymmetric says if A are B, then B are A cannot be in there. So once you have a loop, that is not asymmetric, right? Because you cannot have, if A are B, then cannot be B are A. If there is a loop, you cannot have asymmetry. For anti-symmetric, yes, because it says if A are B and B are A is B, right? So go through one by one, and you can see from here. So this is quite straightforward for all the digraph. Okay. Now let's look at some question. Okay. Sometimes they give a matrix. We have to find the relation. Yeah. You should try all question So much straightforward. Let's try number 6. Okay, you have A is 1, 2, 3, 4. And M is 1, 1, 0, 1, 0, 1, 1, 0, 0, 0, 1, 1, 1, 0, 0, 0. So you have to find the relation and find the digraph. All right, so R equal, so this is 1, 2, 3, 4, 1, 2, 3, 4. So we write from the first row, yeah? 1, 1, 1, 2, 1, 4. That's the first row. 1, 1, 1, 2, 1, 4. 2, 2, 2, 3. Okay, and then 3, 3, 3, 4. And then 4, 1. 1, 2, 3, 4, 5, 6, 7, 8. Okay, you have 8 of them. So this is not reflexive, right? Because there is no 4, 4, not reflexive. There is no 4, 4. Or you say 4, 4 is not in R. This is not symmetric, right? Because you have A RB but not BRA. Transitive is a little bit tricky, right? Transitive, you have to look. 1, 2, 2, 3. There is no 1, 3. So it's not transitive. 1, 2, 2, 3, but not 1, 3. Okay. Maybe there are some others. 2, 3, 3, 4, but not 2, 4. So you have to just find one reason, not transitive. For asymmetric, because you have this, not asymmetric. For anti-symmetry also is not, because you have it, this and this, right? You have this and this. Cannot be. All right, now we have to write draw this digraph. 1, 2, 3, 4. Okay, so 1 to 1, 1 to 2, 1 to 1, 1 to 2, 1 to 4. Just starting from 2, you can see here or here, 2 to 2, 2 to 3. And then you have 3 to 3, 3 to 4, and then there is 4 to 1. Okay. So you see there is no loop here. So it is not reflexive. It is not symmetry because you don't have a 3, 2 here, right? Or you don't have a 2, 1 here. Or you don't have a 3, 4 here. 3 reasons, but just put 1. Okay. All right. Okay, so your assignment would be to try all questions, especially number 21. Okay, especially number 21, because you have to determine whether it is an equivalent relation. Okay, and in our next class next week, we will start with like some kind of tutorial, or I might ask you to present your work or to explain the answer, yeah, in my next class. All right.